Today we'll talk about polynomials and some of their characteristics that help us graph polynomials. Let's start by reviewing transformations. All right, let's look at the parent function. And we just cube all of these and we get these y values. So let's put these coordinates from the parent function into a table like this. And then we have to look at whether we have an inside change or an outside change. Inside change is horizontal, outside is vertical. Let's do on an outside change, we do what it says. On the inside change, we do the inverse of what it says. So we're going to change the y value by multiplying the y value by half. And then we have add 2 to the x value and add 1 to the y value. Add 1 to the y value. And then we're going to add 2 to the x value. We'll go to, let's graph the parent function first, -2, -8. And then let's graph the transformation 0, -3, 1 up a half, 2 up 1, 1.5, and up 5, 2, 3, 4, 5. And we can see that multiplying by half, that's a vertical compression, horizontal translation, and a vertical translation. Pause the video and try this one. Okay, we have inside change of 4. We're going to do the inverse of addition, so we'll subtract 4 from all the x values. Before we do that, let's multiply the y values by 2, and then we'll subtract 3 from the y values. Multiply the y values by 2. And then we're going to do the translations. So we subtract 4 from the x. And then we'll subtract 3 from the y. The parent function, and then we're going to go -6 up 5, -5 up 1, not there, -5 down 1, -4 down 3, -3 down 1, -2 up 5, and here we have a vertical stretch. Translation to the left and translation down. So the graph got stretched vertically. Alright, let's talk about end behavior. We want to be able to just look at a polynomial and know the end behavior. Before we do that, we'll look at the the limit of a polynomial as x goes to infinity. Okay, let's see what's happening to this as we go to the left and to the right. If we put a 10 in here, we get -49 million. If we put a -10 in there, we have +50 million. And at 0, we plug a 0 in there and we get 8. Alright, so we see from this, as we go to the left, y goes to positive infinity. Limit as x goes to negative infinity is positive infinity. The limit as x goes to positive infinity, here we're going to the right, y is going to negative infinity. And over here, look at the same thing as x goes to the left, g goes to positive infinity, and here we have 42,991. Here's 56,991. If you put a 0 in there, that would be the y-intercept. Y-intercept is -9. And the limit of g as x goes to the left is infinity. The limit of g as x goes to the right is infinity. And if we look at what that would be on a graph, we know that as we go to the right, the graph goes up. As we go to the left, the graph goes up. Over here, as we go to the right, the graph goes down. As we go to the left, the graph goes up. And this brings us to a rule. When we look at, in this problem, we only care about the first term, and we don't care what else there is. We're just going to look at that, and we're going to look at that. So in this problem we have negative 5x to the 7th. We don't care what else there is. And over here we have positive 5x to the 4th. And we don't know what else. We don't care what else there is there. So when you have a negative, you can say that means go down to right. When we have a positive, that means go up to the right. And then we have different directions here. And so this happens with an odd exponent. So an odd exponent we go opposite directions, and an even exponent okay, so this tells us up or down to the right, and then we just decide, are we going to go the same direction to the left? So here we're going down to the right, and then we go opposite directions, so that looks like that, down to the right, opposite, and here we're going to go up to the right, and then we're going to go same direction. Okay, pause and describe the end behavior of these functions. So negative means go down to the right. Even means go in the same direction. So they're both doing that. Up here we have x cubed minus some other things. They don't matter. And we look at the front. Positive says go up to the right. Odd means go opposite direction. So we get a shape like that. And we can write these this end behavior as limits. Then here's a different looking question, but we'll use the same rule. So let's determine the end behavior of these, and we don't have to expand it because all we need is the first term, x squared times x, that's x cubed, times another x is x to the fourth, and then we'll just have some other terms after that. All we have to do is look at the sign. That means it's going up to the right, and even means it goes in the same direction. And we could say that the limit as x goes to negative infinity is positive infinity. The limit as x goes to positive infinity is, as x goes to positive infinity, y goes to positive infinity. Okay, pause the video and you try that one. Negative x times x, that's negative x squared, times another x is negative x cubed. And we don't care what else there is. We look at the negative, and that tells us to go down to the right, and then odd means opposite direction. The limit as x goes to negative infinity, as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity, negative infinity. Alright, let's look at some vocabulary. We have to understand these words. And root zeros, x-intercepts, and real zeros can all be used. It's possible they all represent the same thing, and that can be confusing because you have all these different words. So let's look at an example. If we had this polynomial, we want to know the zeros, so we make y 0, and now we have to factor this. We can take x squared out of this, and we can take 4 out of that, and then both of these have x plus 1, and we can take an x plus 1 out. Alright, so let's see what these are called. Their possible names. Our choices are root 0, and we have negative 1, 2i, negative 2i. And negative 1 is a root. Negative 1 is also called a 0. Negative 1 is also called an x-intercept, and it's also called a real 0. 2i is called a root. it is called a 0, but it's not called an x-intercept, and it's not called a real 0, and that'll be the same for negative 2i. And then we have one more vocabulary word called turning point, and we're just going to call these points are called turning points, and it's just where the graph changes its vertical direction. We also can call that a relative minimum, relative maximum, relative minimum, and so there's another word for those relative extrema are called turning points. Alright, possible number of real zeros is 6. And the possible number of turning points is 1 less than 6, so that's 5. This has 6 possible real zeros and 5 possible turning points. Let's go ahead and find the zeros, and that's when we make the y 0. And we want to, here we have a common factor of x to the 4th. Factor out x to the 4th. And then we have a quadratic. We can factor that. We need to multiply to get 12 and add to get negative 8. So those are the zeros. Okay, you try that one. Pause the video. Make the y 0. Common factor of 6x cubed. If we take 6 out of this, there's a 1 left. Take x cubed out of this, and there's x squared left. Take a 6 out of this and get 25, and there's no more x cubed. So now we have this is equal to 0, and or that is equal to 0, square root both sides here. Divide by 6, cube root, and it's 0. So those are the zeros there. And there is one more type of problem to be aware of. Let's find the zeros of this. And if it has this pattern where this number is twice that number, then we can rewrite it and factor it like a quadratic. So we're going to find the zeros. But we're going to rewrite this as x to the 4th squared and we're just going to try to make this look easier to do by, instead of writing x to the 4th, we will just write some other letter, u, because that looks more familiar. We can factor that, and we also have a common factor of 4, so let's divide everything by 4. And we'll divide 0 by 4, which is still 0. And then we can factor, multiply to get 3, add to get 4. But we know that u is actually x to the 4th, so we'll go x to the 4th. And 4th root of both sides, we get that and that. And you try the other one, pause. We need to multiply to get 2 and add to get 3. And u is x cubed. We'll do the cube root. The cube root of a negative is negative, so we'll get -1. And the cube root here, we could just write it as negative cube root of 2. And that's it for today.